Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang and we've got a great episode for you today. We're going to learn a little bit about geometry. We're going to learn in particular about making a container. Luckily for you folks at home tonight, we have a special guest with us. He gets geeky with the geometry. He's a connoisseur of chocolate. You know who I'm talking about. I got J-Cho on my mind. I got J-Cho on my mind.
Say what?
I got J-Cho on my mind. I got J-Cho on my mind.
Thank you.
Hey Jay, how's it going, buddy?
Pretty good. How are you doing?
I'm a little sickish, as you can probably tell.
Yeah.
But show must go on.
Exactly. Show must go on.
So, how is your casino business going? Did you open here yet?
Not exactly.
You having some problems?
Yeah, it's hard to open a casino. You need a lot of money to open one.
Yeah.
I don't have enough money. Unfortunately.
Well, what are you going to do to make some money then?
I was thinking, maybe I should get into chocolate business.
Chocolate business?
Yeah, you like chocolate, right?
Come on. Everyone likes chocolate.
Exactly. That's why I'm like, chocolate business is like safe. You can make a lot of money there.
That's true.
Yeah.
I know that you like to eat chocolate.
Uh-huh.
But what do you know about making chocolate?
Making chocolate? Nothing, I guess.
So how are you going to sell chocolate if you don't know anything about making chocolate?
Well, I don't know how to make chocolates, but I do know geometry.
And how is geometry going to help you sell chocolate?
See, my plan is to make this fancy, use geometry, make this fancy container, put some fancy label, give a fancy name, and ta-da, I can sell a lot of chocolates like that.
So you're saying that people are going to buy the chocolate based on the packaging?
Yeah, exactly.
You're saying that just the packaging, just the superficial exterior is what makes a difference?
Exactly.
Okay. All right. Do you have a particular type of package you have in mind?
Yeah, actually I brought a sample, a prototype. It's a right prism.
Oh.
In particular, it's triangular right prism.
Wow, that's pretty cool. Can I see that? Ooh.
Fancy.
This is fancy.
Yep.
Can you tell our viewers what a right prism is?
Sure. Right prism is a solid that has base on the top. They're identical polygon. And the sides are made out of rectangles. And the sides and the base has to be a right angle. So it's perpendicular.
Oh, okay.
Right. So if you look at it this way, top and the base, they're triangular. Triangles. That's why it's called triangular.
Got it.
If you look at the side, they're rectangles.
Yes, I see that.
Right? And then when you see it, it makes a right angle. It's perpendicular.
Oh, so when you place it flat, the edges kind of go straight up.
Exactly.
I got it.
This is a right prism, right triangular prism.
Why don't we look at a few other examples of some other types of prisms?
Okay. Look at the first one. What do you notice on the base and the top?
That's got a, looks like a five-sided figure there.
So it's pentagon, right?
Right. Pentagon. It's a pentagonal.
Right. And you notice the side is still rectangles, right?
Oh, yeah, I could see that.
Right.
I could see that.
And the next one has 6 sides.
Right.
So it's a hexagon.
Ooh,
So
hexagon.
Hexagonal.
Hexagonal. Gotcha.
Right. And the next one is like,
wow.
What is this thing? A star?
Star prism?
Star prism, I know. So this is pretty flexible. It can be pretty much any shape, as long as the base and the top are identical.
Okay.
It's called a prism. Yes.
Do you have any sort of real-life 3D examples that you could show the viewers?
Yeah, sure. We have, actually, in around us, there are a lot of prisms.
Oh, yeah?
So, for example, this box, are there prisms?
I see. Wait. Is this let me see this. Is this a square prism or is this a rectangular prism?
Well, again, the answer is both. It depends on how you look at it.
Okay.
If you look at it this way, this is the top, this is the base.
Right.
It's a square.
Square, right.
So if you look at it this way,
it's a square prism.
Exactly. However, if you want to look at it this way, top and the base, it's a rectangle. So if you look at it this way, it's a rectangular prism.
Ooh.
Right.
I see.
So it can be either.
Okay, cool. How'd you go about making this awesome little container here?
Right. We have to first construct this thing called prism net.
Why don't you tell our viewers what a prism net is?
Right. Prism net is just a 2-dimensional sketch of 3-dimensional object. Okay. So what it is, when you actually make these boxes, you have to first sketch it on like a piece of paper or on cardboard. Okay. Then we cut it, and then we make the boxes out of it.
Oh, like you sort of have this shape, you cut the shape out, and you fold it up into something.
Exactly.
Okay.
Like those moving boxes.
Oh, yeah.
Because when you get it,
it's all flat.
But then you have to make it into boxes, right?
Right.
So that's like an example of a net.
Okay,
right.
Cool. Why don't we take a look at the prism net that you used for your triangular prism?
Okay. So you notice that there are 3 rectangles, right, in the middle?
Yeah, I see that.
Right, and then you have 2 triangles, and one on the top, one on the bottom.
Right? Oh, those must be the base and then the top.
Exactly.
And then those 3 others are like the sides?
Yeah.
Gotcha. I've heard people talk about something called perimeter. Can you tell our viewers what perimeter means?
Sure. The perimeter is sum of outside edges.
Oh, okay.
It just means the distance or the length around the object, around the polygon.
Oh, okay.
Right.
I think the word perimeter can be broken down into 2 roots, right?
Right.
That P-E-R-I part.
It just means around or outside.
And the meter?
It means just measurement.
Okay.
So you're just measuring what's around it or outside of an object.
Like the cops do.
Yeah.
Like Detective Dr. Richard Abdel Karim does for CSI Pasadena.
Right. What does he do when you go to a crime scene?
Secures the perimeter.
Right. So those yellow tapes they put around
is
literally is a perimeter.
Got it.
Right.
Got it.
So let's look at the perimeter of our net.
Okay.
Right. In this particular example, perimeter is very important for us.
Why?
Because when you make a net, we have to cut the object, right?
Right. We have to cut the shape out. Yeah.
Exactly. When you cut it, whatever you cut is basically the perimeter.
So the amount of cutting that we do is the perimeter.
Exactly.
Oh, okay.
Right.
So can you lead us through, the perimeter, the calculation for the perimeter of our triangular prism net?
Okay. So if you look at the side, it's 10 centimeters tall. So 10 centimeters on each side.
Got it.
If you look at the top part, there are 5 centimeters each. So there are
Right.
4 segments of 5 centimeters.
4 on top and 4 on bottom.
Exactly. It's a total of 5 centimeters.
Yeah.
And 10 centimeters on the sides.
Wait. What about those 2 parts right in the middle?
Oh, I'm glad you asked. So you remember, again, perimeter is what you're cutting. We're not cutting what's inside. We're only cutting what's outside.
Sure.
So even though you see those lines, we're not actually cutting it, so you shouldn't calculate that as
those are like the lines we fold along.
Exactly. So
Gotcha.
that doesn't count as a part of the perimeter.
Okay.
Right.
So
for us, it's going to be basically you just have to add them all up.
Mm-hmm.
So 5 plus 5 plus 5 plus 5, that's 20. 20 on the top, 20 on the bottom, that's 40.
Right.
And then 10 on the side and 10 on the other side, so 20. So altogether, it's going to be 60 centimeters.
Okay. Pretty cool. Another thing I've heard of is surface area.
Right. Surface area or the area is also very important to us.
Can you tell our viewers what surface area means?
Right. So surface area basically is what's contained inside the perimeter. Yes.
So that's what? It's like the amount of material that we're using?
Exactly. So in this case, the area, if you calculate the area of our net, that's how much material we need to construct this box.
Oh, okay.
Right.
Cool. What are the units when we calculate surface area?
Area is measured by square units.
Okay.
So for example, if you have a rectangle, right? The area of the rectangle is base times height.
Yeah.
So let's say base is measured by centimeters.
Right.
Height is measured by centimeters.
Right.
Multiply those two, centimeter times centimeter, hence.
Centimeters squared.
Yes.
I see.
And when you go look for your apartment or whatever, you have like, how big is your apartment, by the way?
Oh, it's 900.
Oh, it's 900.
Live it large.
That's pretty big.
900.
So it's measured by square
feet. I get it. It's like a foot times a foot.
Right. So basically measure your floor space of your apartment.
Gotcha.
Right.
Gotcha. Why don't you lead us through the calculation of the surface area or the amount of material of our triangular prism?
Okay. So first of all, there are 3 rectangles.
Right.
Let's calculate that first.
Okay.
The 2 outside ones, the height is 10.
Right.
The base is 5. The length is 5.
Okay.
So 5 times 10 is 50 centimeters squared.
Right.
The one inside is 10 by 6.
Okay.
So it's going to be 60. 10 times 6 is 60.
Yes.
So if you look at those 3 rectangles, add it up, it's 50 plus 60 plus 50. So it'll give you 150 centimeters squared.
160 centimeters squared?
160, yes.
Got it. What about the triangle? Those triangular parts, can you remind our viewers of how we calculate the area of a triangle?
Sure. Triangle, area of triangle is 1/2 times base times height. Right? So for me, I think of triangle as just half a rectangle.
I gotcha.
Like if you see a rectangle, if you cut a rectangle diagonally, you get a triangle. So it's just half of a rectangle. That's why there's a half there.
That makes it easy to remember.
Right. So for us, is half times base is 6, and the height is 4.
Right.
So 1/2 times 6 times 4 will give you 12 centimeters squared.
Okay.
Right.
And we have 2 of those.
So there's going to be 24. So our grand total is 160 plus 24, so it gets you 184 centimeters squared.
Awesome.
So that's basically how much material we need to build this box.
Got it. I've also heard people talk about volume. What does volume represent in our scenario here?
Volume measures 3-dimensional stuff.
Okay.
So it basically measures how much stuff you can hold.
Like capacity.
Exactly. So if you look at a box, if I had a chocolate syrup, I want to fill this box with chocolate syrup.
Ooh, chocolate syrup.
Basically, volume measures how much chocolate syrup I can fill in this box. It could be chocolate syrup, or it could be water, it can be whatever. Right? Do you ever go buy like a drink, a soda or anything?
Sure.
Right, you buy those 2-liter bottle.
I don't drink soda, but yeah, I know what you mean.
Right. So that measures capacity, which is how much water.
Oh, 2 liters. Liters is a measurement of capacity.
Exactly. That's one example.
Okay.
Right.
Okay. Cool. So how do I calculate the volume of a right prism?
Okay. The volume of the right prism is the area of the base times the height.
Okay. So can you lead us through the calculation for the volume of your awesome little cylinder, right triangular prism you have here?
Cool. Fortunately, we already calculated the area of the base. It was 12 centimeters squared. So height is 10.
Yes.
So it's 12 times 10 is 120 centimeter cube.
120 cubic centimeters.
That's how much chocolate we can pour in there.
Ooh, yummy. Awesome.
120 cubic centimeter of chocolate.
That's cool. That's cool that we were able to learn, a little bit about
So
geometry on our way to becoming incredibly rich.
Selling chocolate with fancy containers. You know what I was thinking? I should make different sizes too. I can sell it in Costco. I can do all these different things.
Yeah, you could make a...
The king size. The gigantic king size one.
You have your...
Regular size.
And you also have?
The mini fun size.
For Halloween.
For Halloween's. Trick or treat.
What other awesome ideas do you have?
Maybe I can make it in with like a fancy material. Maybe there's a gold one, like silver container, and special edition, limited edition platinum boxes.
Well, if you're going to use these expensive materials, when you cut your prism net out, you're going to be wasting stuff. So.
Ooh, yeah. Ooh, wow.
You're going to have to worry about material waste.
Right, efficiency and how much is wasted. Oh, that's very important. Wow.
What other ideas do you have?
I think we should go international.
Ooh,
we want to have branches in every continent.
We got to dream big, man.
Dream big.
Right.
Go big, yes.
If we go international, they'll have to worry about, currency conversion.
Oh, that's true. They use different, like other countries, they use different currencies.
Different measures, the measurement system.
That's
well,
true. That's
we'll
true.
about that later.
Right.
Hey, do you have a good name for your product yet? Because, having a good name is just as important as...
That's true. I have this great, amazing package, but name, I haven't thought about it yet.
I think I've got a special name for your chocolate.
I know you had an idea. I knew you'd come up with a good idea.
I was thinking we could call this Toblerone.
Oh, Toblerone. That's perfect. Woohoo. Amazing.
Chocolates.
You're going to be rich.
Yes.